Ellipse E has equation 25x squared plus 49y squared minus 150x plus 196y equal to 804. We want to find the coordinates of the centre of the ellipse. So part A, in order to find the coordinates of the centre of the ellipse, what I'm going to have to do is I'm going to have to complete the square on these x terms, and I'm going to have to complete the square on these y terms and tidy the whole equation up. So first of all, if I factorise 25 from the x terms, I get 25x squared minus 6x, and then plus, if I factorise 49 from the y squared, then I get 49y squared plus 4y, and this is all equal to 804. So, complete the square inside the bracket. I get 25 x minus 3 squared minus the constant inside the bracket, so minus 3 all squared, plus 49 y plus 2 squared minus the constant inside the bracket, 2 squared, equal to 804. Expand the bracket, remembering to multiply the constant by what's outside the bracket, so I get 25x minus 3 squared minus 9 times 25, which is 225, plus 49 y plus 2 squared. 49 times minus 4 gives me minus 196, equal to 804. So we're almost there. Now what I want to do is get rid of all the constants on the left hand side, so I'm going to add 225 to both sides, and I'm going to add 196 to both sides. When I do so, I get left with 25x minus 3 squared plus 49 y plus 2 squared equal to 804 plus 196 is 1000, plus the 225 gives me 1225. At this point I want single x and single y, so I'm going to divide both sides of the equation by 25, and I'm going to divide both sides of the equation by 49. So this leaves me with x minus 3 squared all over, and when I divide this by 25, the 25 disappears, and then I divide it by 49, so I can only leave that as x minus 3 squared over 49, and then I get y plus 2 squared. So dividing by the 49 cancels, but then I get left with the divide 25 equal to 1. So the centre of my ellipse, well, this is the ellipse with a equal to 7 and b equal to 5, and a transformation on the centre is negative whatever's inside the bracket. So on the x coordinate it's going to be plus 3, and on the y coordinate it's minus 2. Okay, so just making a note here that a squared would be 49, so a is 7, and b squared would be 25, so b is 5. Okay, so let's look at parts B, C and D. So B, C and D, just remembering that the centre is 3 minus 2, and that a is 7 and b is 5. So it asks us for the eccentricity of E. Now since A is greater than B, then we are going to have B squared equals A squared times 1 minus E squared. So substituting our values in, I get 5 squared is equal to 7 squared times 1 minus E squared. Expand the bracket, So I get 25 is equal to 49 minus 49e squared. I'm going to subtract 25 from both sides. I'm going to add 49e squared to both sides, so that we get 49e squared is equal to 49 minus 25, which is 24. Okay, divide both sides by 49, and so I get e squared equals 24 over 49, and then I want to take the square root. Remember, it's just a positive square root, so I get e equals square root of 49 is 7, square root of 24, well, that can be simplified and rewritten because it's root 4 times root 6, so I get 2 root 6. Okay, so that was part B, that was finding the eccentricity. Now I want to find the coordinates of the foci. So this section here, you'll find it in your formula booklet, this little table, so I've just included it on the slide so that we can see what's happening. So this here represents the coordinate of our foci. So part C, if I do the coordinates of the standard ellipse foci, what I get is plus or minus 7 lots of 2 root 6 over 7, comma 0, which when I tidy it up comes out as plus or minus 2 root 6, 0. Now, actually, so I'll just label this is a standard ellipse where the centre is 0, 0. Actually, my ellipse has been transformed by the vector 3, 2. So it's been translated 3 minus 2. So in fact, the foci will be translating the x-coordinate 3 in the x direction. I get 3 plus or minus 2 root 6. Transform 0 minus 2 in the y direction. I get minus 2. Okay then, finally, the equation of the directrices again. We'll state the equation of the standard directrices. So here's the equation of the standard directrices. So let's label this part C, so it's clear, and this will be part B. So the equation of the standard directrices would be x plus or minus, sorry, not x plus or minus, it's going to be x equals to plus or minus a, which is 7, over e, which is 2 root 6 over 7. So when I flip that fraction upside down and multiply by it, so we get x plus x equals, plus or minus 49 over 2 root 6. Now, again, this is for the standard ellipse. So this has also been translated by the vector 3 minus 2. So this leads to, well, this relates nothing to the y values, so what we get is x equals 3 plus or minus, because it's translated 3 in the x direction, 3 plus or minus 49 over 2 root 6. Okay, well I hope that all made sense and that you understood that question.